Here are the answers to the last Do You Know It? For number one, from section 8.2, we have some negative exponents. Anytime we have those negative exponents, what we want to do is we want to first identify where those negative exponents are and which numbers or variables they're affecting. So I like to circle them. Then I'm going to shoot them. If they're on the bottom, I'm going to shoot it to the top. If it's on the top, I'm going to shoot it to the bottom. This then will give us a 12 and a 3. The y comes up top. The x goes to the bottom. I can still simplify this because 12 divided by 3 I know is 4. This is y squared up top and x squared. I can't combine these two, the y and the x's, because they're not like terms. So this is the answer we're looking for. Number two, we have a lot of powers raised to the 0 power. So 0, anything raised to the 0 power, is going to give you 1. So this is 1. Negative x, all raised to the 0 power. Again, this will give you 1. 1 times 1 is 1. Section 8.3. If you want, you can write it out. You don't have to write it out if you don't want to, but if you wanted to write it out, you could. And what we are going to do is, I'm just going to look at it and I'm going to say for my x's, I see there's 7 x's on the bottom, there's 6 x's on top. So that means that there's 1 extra x on the bottom. So I'm going to leave an x on the bottom. For my y's, I see there's 7 y's on top and 6 y's on the bottom, so that I know there's 1 more y up top. So we were looking for y over x. For number 2, it might help when you're doing a problem like this if you combine like terms. So 3 times 3 gives you 9. I have an x squared, and then I have 3 y's and another y, which gives me 4y, or y to the 4th. 4 can combine with anything, so I leave that alone. X times y to the 5th. Now, if I'm doing this, obviously 9 and 4, they can't cancel out, so I leave those alone. If you look, sorry, I was off the screen. If you look, I have more x's on the top than I do the bottom. I have 1 more x on the top than I do the bottom, so I leave that up top. For my y's, I have 1 more y on the bottom than I do up top, so that is going to be 4y. Good. 8.4. I'm writing this one into decimal notation. So if I write this into decimal notation, first thing I do is I write 3, and my decimal is currently here. Since it's a -2, I'm going to move it 2 places to the left, just like in a number line. In a number line, the negative numbers are to the left and the positive numbers are to the right. So I move this over 2 places. I fill in those decimal points, so my answer will be 0.03. For my next one, that's a 1, not an exclamation mark. What we want to do for this one is we are going to write this into scientific notation. To write in scientific notation, I know there has to be 1 digit to the left of the decimal place. So automatically this becomes 1 point. I have to write all the numbers that are to the right. I don't have to include these zeros, but I do have to include all these units right here. Then I write times 10, and I have to figure out how many I moved over. So it was here. I moved over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be a 10th power. I then have to figure out, is this a negative or a positive? Well, if I'm taking this number, in order to make it this huge number, I have to move it to the right, which on the number line is to the right. And those are all the positive numbers. So my answer is 1.234321 times 10 to the 10th power. Number 3, I have to change this to scientific notation. So 1 decimal has to be to the left, or 1 digit has to be left of the decimal. So 4.1 times 10, and I have to figure out how many places to move it. It's currently here. So 1, 2, 3, 4, 5, 6, 7. So 4.1 times 10 to the 7th power. Again, this will be positive because if I take 4.1 and I move it, I have to move it 7 places to the right, and that is in the positive direction on a number line. All right, section 8.5 and 8.6. These were the word problems. So hopefully you have your test in front of you. But what it says is you purchase a parcel of land for $2,500. So if I have a parcel of land, I know that this is $2,500. I know that the percent is 11%. And I know the time is in 8 years. This is an example. Since you purchased the land and it depreciates, it's exponential decay. So I'm going to use the formula y is equal to my original amount, 2,500. I have 100%, and I'm going to subtract 11%. I'm going to raise this to t. So this will be y equals 2,500. 100% minus 11% is 89%. Raise the t value. Now to work with it mathematically, I have to change it over. And I can't say 89%. So instead what I have to do is I have to, instead of writing 89%, I have to write 0.89. It's 8 years. If I plug this into my calculator, you should get $984.15. On the second one, my original price was $100. The percent is 7.5%, and the time is 5 years. It says that it's compounded yearly, so that's going to be an increase, exponential growth. So I'm going to do y equals my original value, 100. I start off with 100%, and I'm going to add to this. I'm going to add 7.5% to this. This will become y is equal to 100. If I add these two numbers, I get 107.5%. If I change it so I can work with it mathematically, I'm going to move my decimal point to the left 2 places. So 1.075. And this is raised to my time, the 5th power. And if I enter this in my calculator, I should get $143.56. All right, 9.1. In order to do 9.1, I have a square and I have 100. If you want to, you can think about 100 as being 10 squared. You'll notice both of these numbers have a squared. To get rid of the squared, we have to take the square root. In an equation, anytime I take the square root of both sides, I have to, wherever my variable is not, write plus or minus 10. So this is x equals plus or minus 10. On number 2, I need to solve this equation, so I'm going to begin by subtracting 3. I get negative 5x squared equals negative 15. I divide by negative 5. X squared is equal to 3. Here's my square root, so I have to take the square root. It's an equation, so where my variable is not, I have to write plus or minus square root of 3. I don't want to change square root of 3 because that's a perfect answer, whereas if I write it as a decimal, then I'm going to have to round it. All right, section 9.2. If I'm doing this, first off, square root of 81 is 9. Do I have to write plus or minus? No, because this is not an equation, it's an expression. Square root of 48. We're looking for a perfect square that goes into square root of 48. I know that 16 goes into it 3 times. So the square root of 16 is 4 root 3 over 9. 4 and 9, there's no common denominators or common factors that go into both 4 and 9. So that's your answer. Number 2, I'm looking for a perfect square that goes into 20. So I know square root of 4 times the square root of 5 is 20. I know square root of 4 is 2. Half of 2, if you have $2, what's half of it? It's $1. And we don't want to write 1 root 5, we just want to say square root of 5. And then the last one, number 9.3, what we have is we want to find the solution. The solution is where it crosses my x-axis. So the places where it crosses my x-axis is x equals 1 and also x equals -3.